I think the... OK, so let's get started. So Pac Man. First, before I think get into the subject, since I've just realized this is like the farthest I've got from my hometown, like to give a talk. So first time this side of the world is really exciting. The community here is very friendly. Thanks a lot for that. So I'm a Brazilian. I'm now living in London for the past like 4 to 5 months. Like they said in introduction, actually I'm used to be a runner, but I got a knee injury. I'm working on that. I still want to do a half marathon. Somebody earlier today talked about cats and dog person. I'm a cat person. And I work in IT since about 2004-ish, because as you know, I switched careers a few times. But nowadays, I'm a software engineer, or some would say data engineer at GoCardless. And just a small token of appreciation for GoCardless, because they helped me get here. GoCardless is a fintech based in London that their purpose is to make payments simpler, recurring payments specifically. And of course, we are hiring. If you want to know more about this, please let me know. Maybe try life in London. But OK, this talk is not about actually something that I do in my job. I don't write games. But it's about Pac Man. And for those who doesn't know Pac Man, there's basically the game where there's this yellow thingy that escapes from ghosts and eat dots in a maze. Probably most of you will remember the game by this design, but I remember the game by this design. And for those who doesn't know, this is the Atari 2600 version of the game. And I was doing like a introspection before placing this picture, and it's probably because that game that I'm here today, because all my passion about software engineering, software development started in my childhood when I used to play those kind of games. And it's kind of poetic that I'm here talking about this. But this is not actually about just a game. The idea behind this talk started like 2 years ago, a bit more maybe, when I was still back in Brazil in 2017. And I was starting the Women Who Go chapter of Porto Alegre. That was the city I was living in. And we wanted to have like a Women Who Go workshop that would be out of ordinary, that will bring excitement to the women that were getting introduced to Go. And we thought, why not building a game? And so that's when this project started, and I got like that feeling again that, hey, I want to try building games and stuff. So we did the first version back in 2017, but we were just learning Go. And the first version was not very idiomatic. The code was, I'd say, pretty bad. It was also in Portuguese, so it was not very useful to the rest of the world. So in the beginning of this year, I decided to take back that project and rewrite it. And this is the product. So before getting to the code, I promise I have like 3 slides more, and the rest is just code. But we need to know 2 basic concepts. First, we are going to use the terminal as a screen, because that makes things easier. And the terminal can run basically in 3 different types of modes. One is the cooked mode, other is break mode, and other raw mode. Basically, the cooked mode, what it does is intercept every keystroke you press and pre-process it for you. For instance, if you have a signal like Control-C, it will process for you and interrupt the process that's running. Or the arrow keys, they have different meanings depending on the type of terminal. So the cooked mode pre-processes that for you. The raw mode does the exact opposite. It doesn't pre-process anything. And the break mode, you can imagine that it's a mix in between. It processes some signals, and some it doesn't process. We're going to use that mode because I want to process the arrow keys myself. Another thing we need to know is a bit about terminal magic, that what's called ANSI escape sequences. And these are things that you print to the terminal and have special meaning. Instead of printing text, for instance, we can print an escape sequence that starts with the X code for ASCII, the square bracket, and bytes that have different meanings depending on the type of the command you want to do. And basically here I'm using escape sequence to move the cursor, clear the screen, and so we can have control where we are plotting. That's all my slides if you want to grab the QR code, but then let's show how it works. So it's really important that this was designed to be a tutorial, so I'm going to move like in a really fast pace here, but I'm going to like show you some highlights. This is the very first file that you get to see when you open the tutorial. It's basically an empty main function with some comments. And if you ever tried game programming, you have this concept of a game loop. And I left like placeholders for every step, everything that you need to process in the game loop. Game loop is basically an infinite-ish kind of loop that you break only when the game's over, like the player wants to quit or what else. So here's a simple hello world writing the game loop style. The size of the font is OK, or do I need to increase it? OK, maybe one more, I don't know. I'm here, this is my terminal. So nothing really exciting, it's just hello. OK, so next step in the tutorial is this. So we have these folders that are the steps. And the whole tutorial, if you go to GitHub, it has like the text documenting each step. But here, what we're going to do, we have this maze txt. That's the ASCII representation of the maze. So the hash sign is the walls, the P is the player, the dots are the dots in the maze, G is the ghost, and X's are the power-up pills. We are not going to implement those today. But this is the representation. So the first step, obvious step, is to load this in memory. So we have this function called load maze that will load the text file. And basically, our maze representation is, let's see if I got this, a slice of strings. So we're just loading each string. And we have a print screen function that will loop through every line and just print into the screen. For now, we don't need much intelligence. So we are starting to replace those comments with actual code. So load the maze is there, and in the game loop, we have a print screen. And we still have like a temporary break just to break the infinite loop. And let's see this code in action. For now, not many surprises there. So just print the ASCII representation of the map. OK. So next step. So now that we have the maze, we need to start like setting the ground for printing the screen and reading input. So we're going to create this move cursor using that like escape sequence magic. And also we have this clear screen function to give the illusion of animation. So before printing each screen, each frame, we clear the screen, print it all over again. We also have this input function that the whole idea here is like to capture the ASCII for now, but this is where we are going to process the arrow keys as well. You may notice there's an interesting part here that I'm using like, I don't know, 100, like a buffer of 100 bytes, but I'm reading just one. And you see that later I'm just reading like 3 at a time as well. So is that a bug? No, it's not. The idea is that I don't want to buffer keystrokes. I want to process as they come in. So let's say the player is like escaping for a ghost. He pressed 100 times the left arrow key. I don't want to process actually 100 times. Maybe in the middle of the course he changed his mind and pressed up. And I want to have this kind of precision. Also, As this is a tutorial, I'm using some liberties that I probably would not use in the real-world code. For instance, here I'm initializing the cbreak mode of the terminal using the init function. But it doesn't really need to be the init function. It's just to say, like, for those who don't know, init function is a special function that runs before main, and you don't need to call it. So it's kind of like I'm taking some like poetic liberties to use some features during this tutorial that are not necessarily needed, just to show they exist. So now we have like this cleanup function that's called to restore the terminal to the cooked mode. We have this read input that takes, for now, it only processes the escape key. And now I can replace that break with the escape. And basically, it doesn't look like a different code. But now the biggest benefit of this code is that I can have like a clean exit. Also, if I press anything, it would be animated, but let me try this more. Yeah, I think it's better. So anyway, let's escape. Fine. Nothing is happening so far, but so let's add some movement to it. So first thing we're going to implement is the player character. So we have this player struct, and the player is a player. We are handling only a single player for now. And we need to keep track the position of the player. So when we load the map now, we just like lazily load to the maze slice as usual. But now we loop through the maze and create a player struct in the position we find the P. Simple enough. We're also making some changes to the print screen because now we can't just like lazily print the maze all the time. We need to actually be aware of everything is. So I'm replacing the code with print screen. I'm just printing the walls first, and then I have this additional code to print the player. And for now, we're just using the ASCII codes as well. And here's the code that treats the input. So the arrow keys, they have this structure that they are a 3-byte sequence that starts with ask, then has this square bracket, left square bracket, and followed by the letter A, B, C, or D. And we need a few more things to help this work. This is the make move function that basically what it does is take the direction and make the corrections to the player position with a specific check to see if the new position is a wall. If it is, it basically just ignores everything it does and restores the old values. So, and here I'm using, like, again, just for fun, named return parameters. I know some people hate those things. It's just to show that this thing exists, not really needed here. Without all that boilerplate done, like moving the player is really trivial. It's just we call like make move with a given direction. And if it doesn't hit a wall, it will update its position. And the game loop is basically, you would just add like move player input after processing the input. So let's go to the terminal. This is step 3. And you can see now I'm not printing anything else except the P, but the P works, it's moving. And it has also that nice effect of if I leave the map from one end, it appears on the other. Okay, seems to be working. Next step is to add some ghosts. And the ghost code is pretty similar to what we've seen before. So with a few difference, but the ghosts just have like a row and call. But instead of having only one ghost, we now have like a slice of ghosts. And I'm specifically using a slice of pointers to ghosts because I want to update like their position in an easy way with using a range loop. You will see that in a second. The code for handling the ghosts is pretty much the same. We're just like every time we found a G in the map, we append to the ghost slice, creating a new ghost. Also, the print part of it. So we print the screen, print the walls, then print the player, then print the ghosts. Pretty trivial. And the algorithm, very advanced algorithm for moving ghosts is just like this, is draw direction. So we are handling, picking up a direction between up, down, right, and left. Try to move it. If it doesn't move, it's OK. But it works. Kind of, it's a good enough algorithm for now. And in the game loop, it's just a matter of like, we just need to add like move ghosts now. Pretty simple. So you'll see that now I have the P, but the ghosts are not moving, of course, because I have a main issue in my code is that the input, to read the key from the player is a blocking operation, but we'll fix that soon enough. But the ghosts are like randomly starting to leave their cage, so it's work. But before we get into that, we need to actually, this is not a proper game without like game win and game over conditions. So now we're going to add both a score variable. We are going to count the number of the dots in the maze because we want the game to end when we eat all the dots. And I'm giving the player 1 life. It should be trivial to extend this to support multiple lives, but I'm just like, for now it's binary. If the player gets hit, it's kill. And the code that counts the dots is the same code that creates the player and creates the ghosts. We're just like adding to the number of dots every time we find a dot. And we have this also, just for curiosity, the code that prints the wall is the same that prints the dot, and so I use a fall through just to show that it exists. And finally, when the player moves, we need to be aware that when it hits a dot, there's a dot below it. We increase the score, decrease the number of dots, and then we remove the dot from the maze. And here's really important to note, since we are using a slice of strings to represent it. We're basically, and the strings are immutable. We need to create a new string, so using some clever slicing to remove that character from the string and build a new string with like an empty space in the middle, where it was supposed to be the dot. So now we have only one change to the game loop. That now we have the condition for the winning, number dots equals to 0, and we also have the processing for collisions. Basically, we just like loop through every ghost and check if it's in the same position of the player, and repeat forever. So the results of it is, let's clear the screen. Step 5. So of course, I removed all the dots because I don't want to stay here forever to test this. But if I hit the 3 dots, there's a bug there because it doesn't print the last frame. But game win is tested, and also game over. Here, at some point, the game stops. OK. Seems to be working. Now, let's get to the fun part. So we have a game that works, but it's not fun because the ghosts only move when I move. And what came to your mind when we want to solve this kind of problem? If you only Go had something to help us with concurrency, maybe. And luckily, it does. And that's the beauty of it. It's a really simple change that we're using a very standard concurrency pattern. We just create a goroutine that will be responsible for reading the input that can block as much as it wants. And we have a channel to communicate with the game loop. But we need to make sure this channel is read in a synchronous way, so it doesn't block the rest of the processing. So it has this default clause. And also now, since we're not blocking anymore to make the animation works, we need to introduce a delay. So 200 milliseconds, this means that the game runs at 5 frames per second. And so here it is, step 6. And voila, the Gs are moving by themselves, and I can move the player, and so on. So, OK, the game works, but I promise you emojis. And so it's not so fun to look at the black screen, right? Or white. So the idea is to use a config struct, and since Go's like natively support Unicode, it's really easy. I made some random mappings just to give some color, like the dots are cheese and the walls are cactus, but in the end it should work. And so we have this config struct, and basically we need to like declare this, and whenever we print any of those, of course we need a function to load the config file, and whenever we print those things, where's print screen, instead of printing the actual character, we just print like the figures we got from the config struct. I also added some, where's the move cursor? I had to add some displacement here. So there's this flag, use emoji, because emojis are usually 2 bytes long. And if we mix like space that's a single byte with emojis that are 2 bytes, we can get like this weird layout. So basically, this code is just scaling it. If you decide to use emoji, you need to set it to true. And it kind of shows that we have a very nice feature that was used like in game design for like the old games, is that usually you have a collision mask structure, and you have like the screen are different things. And we are using the unscaled map to detect collisions, but the code that prints is completely different. And this should make like the change to do like printing like in a real graphical screen pretty straightforward. So if you ever decide to move to like a graphical library, and in the main function, we only need to basically load the config before loading the game, and the rest is basically the same. I added some that emoji as well, just for fun. So here it is, step 7. And that's it. That's the maze. We have some colors, and we have some cheese, and the Pac Man can actually die. So there's a little skull there anywhere. So that's it. That's the tutorial. I have a few more steps moving forward. There's a new step, the step 8, that's about flags. But in the future, there are many things in the language that were not covered, like testing, interface, receiver methods, overall game improvements, maybe someday real graphics, playing with WebAssembly. It's open source. Please submit PRs. I just want to show you some fun I've been trying to do. I have created this step X that's, I don't know yet how I implement this in the overall tutorial, but there's this pink ghost that chases you forever. And this is my first try implementing like an A-star pathfinding algorithm, if you're interested in that kind of thing. The most interesting thing about this kind of game is it's simple enough if you want to test algorithms and stuff. And also, I think it's a fun way to learn the language, try new things. So please feel free to contribute. Like if you have any comments, want to raise issues. The only known issue is that it doesn't work in Windows. I'm not sure if anyone here uses Windows, but maybe you need to find like a terminal emulator to do that. It has been tested on Mac and Linux. It works well. But anyway, that's it. I had to show you. Have any questions, please let me know.
Thank you, Daniela.